video comes from the EduTech studio of V.V. Vanniyaperumal College for Women, Virudhunagar, which is the renowned institution re-accredited with A++ by NAAC in the 4th cycle. I am Dr. M. Ponniyin Selvi, Associate Professor of Commerce. In this video, we are going to see about hypothesis and testing of hypothesis. These contents are studied in both statistics course and also in research methodology course. First, let us see what is a hypothesis. A hypothesis is an assumption. It is a tentative statement which is going to explain the relationship between two or more variables. Let us take for example the expenses made for advertisement and the amount of sales. These two are two variables. So whether two variables are related, in what way they are related, based on these, some statement can be formulated. Such a statement, such assumption is termed as hypothesis. And the hypothesis can be framed in many ways. Based on the contents, the terms and the expression, the hypothesis can be divided into many parts. The first type of hypothesis, of course it is not a part, it is a type of hypothesis. We can say it as a null hypothesis. The null hypothesis states that there is no relationship between the variables under the study. Let me again say that there is no relationship between the amount of advertisement expenditure and the amount of sales volume. So when we say that there is no relationship, there is no impact, then it is termed as null hypothesis. The next type is known as alternative hypothesis. It is just the opposite of null hypothesis. Whenever we say that there is relationship between two or more variables, it can be stated as alternative hypothesis. When the null hypothesis is denoted by H0, the alternative hypothesis can be denoted by H1 or HA or sometimes H alpha. In Greek small letter word, we can denote it as H alpha also. When the hypothesis sentence is going to state the relationship, whether there is positive relationship or whether there is negative relationship, the direction, when it is going to state the direction of relationship, such a statement, such a hypothesis is called as directional hypothesis. For example, we can say an increase in advertisement increases the amount of sales. So here the direction is mentioned. Whenever the amount of advertisement expenditure is going to be increased, the sales volume is also going to be increased. So here the direction is positive direction. If suppose the direction is not mentioned in the hypothesis, then such hypothesis can be termed as non-directional hypothesis. So whatever may be the type of hypothesis, hypothesis must be formulated first. So in testing of hypothesis, there are various steps. The first step is we have to state the hypothesis. There is no significant relationship between the advertisement expenditure and the sales expenditure. Like that we have to frame. Mostly we are going to frame null hypothesis. We are going to test only the null hypothesis. After defining the hypothesis, the next step is we have to mention about the statistic test tool, the probability distribution. Mostly the probability distribution we have to assume is the normal probability distribution. In the normal probability distribution, we generally mention that the distribution is based on a bell-shaped curve. The curve goes like this bell-shaped curve. So here we can state that if the sample size is more than 30, it is termed as large sample. For large sample, we can use the test is a test. For small samples, we can use the test t-test. And in general, we can use f-test for both the categories. So here in this video, I am just going to state only about these three tests. T-test, Z-test and F-test. When we talk about any test, then we should decide whether it is, see here we are talking about identify the test statistic. Here the test statistic may be either t-test, z-test or f-test. The probability distribution. The probability what we are going to deal is mostly normally distributed data. Then the next one is the significance level. Whatever may be our endeavor, there may be chances for error. The error may be due to sampling error or non-sampling error. The error can come under two categories and we are going to denote it as type 1 error and type 2 error. The type 1 error is denoted by alpha and type B error is denoted by beta. The error which is most danger is type 2 error. Type 2 error means the hypothesis itself is wrong and our test is going to accept the hypothesis. So it is the most dangerous error. So we have to avoid, we have to reduce the type 2 error. If we have to reduce the type 2 error, there must be some sort of expansion. Some spot should be there for type 1 error. So that type 1 error is in another form termed as level of significance. In other way it can be told as level of confidence. If the confidence level is to be 95%, then the type 1 error permits for 5% level of significant difference. So here level of significance may be generally 5% or 10% or 1%. That means the rejection. In two-tailed test, the rejection area will be on both the left end and also on the right end. For example, when any person is taken for army or any physically fitted job, there may be height and weight restriction. If they are underweight, they may be rejected. And at the same time, if they are overweight, they may be rejected. So in such cases, the rejection area falls under two sides, both sides. Hence it is called as two-tailed test. On the other hand, sometimes the rejection area may be on only one side. So when the rejection area is on only one side of the normal probability distribution, it is termed as one-tailed test. Again, the one-tailed test may be either right-tailed or left-tailed. Here, right-tailed test is it. That means, suppose when we are producing one particular product and that particular product should have the maximum of 3% chemical in it. That is, the maximum percentage is 3%. If the chemical is more than 3%, then the product, the statistical quality test will reject the product. So when the content increases 3%, it will be automatically rejected, isn't it? So in such case, it is one-tail test because the rejection area is on only one side. So here the null hypothesis what we are stating is the mu, that is our expected mean, and we are comparing here our expected mean and our observed mean we can compare. It may be less than or equal. So these areas can be accepted. Only when it is more than the particular limit, particular criterion, then it will be rejected. There were three simple tests. The t-test is for small sample test. When the sample size is less than 30, we can apply t-test. So, previously we learnt about steps. Here we have determined the significance level, whether it is 5% or 1% or 10% we can determine. Now we are coming to the decision rule. To come into the decision rule, we are in need of two things. One thing is data. We need the data and we have to do the calculation. The data what we need is the variable. With the help of the variable, we can calculate X bar, standard deviation, correlation, and whatever is needed for our study, we can calculate. So after collecting the data, we have to perform the calculations. To perform the calculations, we need formulas. If we have to find out the t value, see, t-test is the test used for small samples. Small samples means less than 30. So here, the standard mu may be the standard, that is the uniform. For example, the average life of a particular mixie, particular brand mixie is 10 years. So here 10 years is mu. And what is X bar means? It may be the average life of actual production in 1 year. In 1 year, a particular company may manufacture 1000 mixies. So for the 1000 mixies, it has to find out the lifetime. So it is find out the X bar, the average lifetime of those mixies, those particular set of observed data. Now these two are to be compared. These two are the variables. So now our null hypothesis will be there is no significant relationship, or we can say that there is no change between the mean life of the standard mixie variable and the observed or actual production mixies. So the standard life what they told was 10 years and our average may come as 9 years. So X bar may be 9 and mu may be 10. And for all those 100 mixies, we can find out yes is the standard deviation. And here we have to find out standard error by applying the formula S divided by root n. N refers to number of samples. The number of samples should be less than 30. Then only we have to use this one. If the sample is 100 means we have to go for Z test. In case of T test, only if the sample is less than 30, we are going to use and we are applying this formula and we are finding out the T value. Suppose the T can be used for two sample, the same set of students. For example, the first year students' performance is measured. Their average mark is measured. And at the same time, when they are coming for the second year, their performance is also measured. So now the average mark during their first year is one criteria and the average mark during their second year is another criteria. So here we can compare both average mark. Suppose these samples differ. For example, in first year it may be A section and in second year we can compare them with the B section, means the sample size are different. So here this formula deals with N1. It is the sample size of first year A section students, and N2, it is the sample size of second year B section students. So here the two samples are not the same sample. They are independent. So here we are applying the formula T is equal to X bar 1 minus X bar 2 divided by root of X1 S1, that is standard deviation 1 square by N1 plus standard deviation 2 squared by N2 to find out the T value. And in case of Z, this Z can be applied for large sample. Here also we are comparing only the same variance between these two parameters. But the standard error is standard deviation divided by root n we are mentioning. And another test is F test. This F test is for measuring the variables variances, that is standard deviation square. S1 square divided by S2 square. Only the formulas are different. So from the above slides we find out either T value or Z value or F value. After finding out these values, see what we found out are called as calculated values. Now we have to compare this with the table value, the critical value, To find out the table value or critical value, we should know degrees of freedom. In statistics, we can say that degrees of freedom means how far the variables can have their own values, how far, to what extent, for the given constraint. For example, in a class there are 5 students in a group. The total of the 5 students mark is 50. So, how can we have the data? For the first 4 students, we can have any number of data. It may be 8, 12, 16, like that we can have any number of data. But for the 5th one, we cannot have any one data, only the constraint is 50. So we can have only one answer we can have for the 5th variable. So there we don't have the freedom for the 5th unit. We are having the freedom only for the first 4 data. So generally the formula for degrees of freedom is n minus r. N refers to the sample size and r refers to the number of parameters, that is which cannot be, the number of constraints. Generally for t-test we use the term, if it is single variable and a single parameter, we use the term n minus 1. So after knowing about the degrees of freedom only, we can find out the table value, that is the critical value. How we can find out the critical value means, we have to understand 2 things. The first one, as we quoted in our earlier slide, significance level, whether it is 5% or 1%. These 2 are mostly used percentages. Then the next one we have to decide about tail, whether it is 1-tail test or 2-tail test. Then deciding about the degrees of freedom. After knowing these 3 things, we can refer the table. For example, in this table, we are going to find out the degrees of freedom. What we are having is 24 here we are having. Suppose the sample size is 25 means we are applying the formula n minus 1. So 24. For 24 at 5%, what we can have at 5%, here we can quote the value as 0.685. So there in the row heading we are having the level of significance, and for row head we are having degrees of freedom. So now what we take is called as the critical value. Suppose if it is F distribution, there are 2 variables and one variable can be given in the numerator and another variable denotes the denominator. So here on both sides we are having only the degrees of freedom. So based on those degrees of freedom, here in this example we have highlighted there are 10 variables in first category and there are 20 variables in the second category. So for the first one 10 minus 1 9. For 9, here 20 minus 1 19. Here we are having the value 3.5225. So it is the critical F value. Suppose if it is Z test, here we are using the term either area or probability. Here how we can find out is, we can find out for minus 2.67. So here how I am taking minus 2.6 in the row level and coming to the column 0.07. So what we are having is 0.00379. It is our answer. Here why we use the term minus means the area falls to the left. In the Z test I told you it is a bell shaped curve, and in the bell shaped curve what comes this left side. So if our probability comes under this left side, the area is denoted by minus. So only in the Z table we use the minus 2.67, like that we have used. So from these slides what we have understood is how to find out the critical value. So previously by applying the formula we calculated the real value, formula value, calculated value. From the table value what we are finding out is called as the table value, that is the critical value. Now we are going to compare these two. When comparing, if the calculated value is less than the table value, then we can accept our null hypothesis. So in testing of hypothesis, our first step was just to state the hypothesis. The hypothesis what we framed was, there was no difference in the sales due to advertisement. So there is no improvement, there is no impact. It was our null hypothesis. And in the sixth step, we are comparing the table value and the calculated value. Calculated value was found out by applying the formula. Table value was found out from the table given already by the statisticians. When comparing, if the table value is higher, that is, if the calculated value is less than the table value, the null hypothesis is accepted. The null hypothesis accepted means there is no use of giving advertisement. So now we can make our final decision as we need not invest in advertisement campaign, because even if we advertise in any channel or any media, our sales is not improving, increasing. So we can decide that there is no need for advertising. So such decisions can be taken by using hypothesis and by applying hypothesis testing techniques. Thank you.